Now the same filtering I'm going to do, but I'm going to add sine wave with noise and I'm going to filter. Okay, so I'm going to add sine wave and noise. So see, I'm creating two sine wave. One is 1K, one is 10K. I'm going to create two sine wave and I'm going to create a low pass filter. And it will pass all the signals till 5K. So it will pass till 5K and after 5K it will not allow any signal. Okay. And I'm spectrum analyzer also I am initializing. Now here you see I'm adding the two sine waves plus noise. I'm adding the two sine waves plus I'm adding a random Gaussian noise. So you know whenever you are going to add noise to a signal, the signal will not be a proper sine wave. Immediately after adding noise, I'm filtering the signal to see what is the resulting answer. So I'm also very eager to see what is the answer you will get. You're able to see this is the output. So this is the original noisy signal. Original signal is given in yellow. This is spectrum analyzer again. So original signal has two peaks. What are the two peaks? One at 1K, another one at 10K. That is what we are given in the code, right? 1E3 and 10E3, 1K and 10K, 1000 hertz and 10,000, sorry, 1 kilohertz and 10 kilohertz to be simple, right? So initially in the input signal, both the 1K and 10K is there. After filtering, 1K is there, this 10K is not there. See the filtered signal, this blue one is the filtered signal. Where has this 10K gone? See, I am doing a low pass filter. Low pass filter means it allows only low frequency 1K. It is going to block the high frequency 10K. And what is the cutoff frequency I have given? 5000. Anything less than 5000 will be passed. Anything more than 5000 will be stopped. And you are beautifully visualizing the same thing in a spectrum analyzer. Okay, this is a simple filtering. We have seen how to do filtering using MATLAB. Okay, and theoretically you can write code and whatever output you see, you can be convinced with that. But only when you see the result using spectrum analyzer, you can clearly visualize what frequency is getting filtered, what frequency is getting eliminated. That is available only when you see the spectrum analyzer. I think you are able to see the spectrum analyzer. No means I'll just show you the spectrum analyzer. I think the spectrum analyzer is visible to you now. See, this is the spectrum analyzer. See the yellow signal that has two peaks, one at 1K and 10K. And see the blue signal is the filtered version. It is having only the 1K, the 10K is filtered. So 10K signal is output. But input you see, I have both the signals and you have lot of noise. You have lot of noise. Okay, that is what is evident from the spectrum analyzer. And see, I will just make one change the code. I will remove the noise and we'll see the perfect sine wave. I'll just remove the noise in the code. Wherever I have this noise, right? I'll just write, I'll just comment this and see here. I will uncomment this. I'm just having the sine wave also. Now I'm going to run. Now also I'll be getting a spectrum analyzer. I'll show you the spectrum analyzer when I get it. Yes. I'll share the spectrum analyzer now. Please see the spectrum analyzer. You can feel the difference without noise. Able to feel in the difference? You get exactly two peaks. And finally filtered signal is blue one, and in blue one you don't see a second peak. Yes, so it is completely filtered. It's completely filtered. So this is how things are happening using MATLAB.